Have you at any point contemplated whether we're genuinely alone in the universe? Or then again, if there's something else to our reality besides what we see? Consider the possibility that the James Webb Telescope finally demonstrates that we live inside a black hole. Join us as we look further into this pivotal news that will make you question all that you assumed you knew about the universe. So, what precisely are black holes? They're similar to something out of a bad dream. Sure, you could have seen them in science fiction films, but in reality, they're much more frightening. According to researchers, they're not just totally dark openings in space. They're actually monstrous amounts of matter fit into an extraordinarily small region. Consider a star multiple times more enormous than the Sun, all pressed into a sphere the size of New York City. The gravitational pull is so intense that nothing, not even light, can escape from it. Researchers have been entranced by black holes for quite some time since they study objects in space so huge and dense that they could trap light. The most popular ideas about black holes were predicted by Einstein's theory of general relativity. Basically, when a massive star dies, it leaves behind a tiny, dense core. If this core's mass is 3 times that of the Sun, gravity overwhelms everything else, leading to the formation of a black hole. Detecting black holes is no simple task, as they produce no light. However, researchers have found ways to deduce their presence by observing their effects on neighboring matter. For instance, if a black hole passes through a cloud of interstellar matter, it'll pull that matter toward it in a process called accretion. Moreover, when a normal star gets too close to a black hole, it can be torn apart, emitting X-rays as it does so. Black holes also significantly affect their surroundings. They can consume nearby stars, emit powerful gamma-ray bursts, and even influence the formation of new stars in some areas while slowing it down in others. But where do black holes come from? Picture this. Stars, once magnificent and blazing, meet their ultimate demise in a colossal explosion called a supernova. From the remnants of these fallen giants, black holes arise. Most black holes are born from massive stars that have reached their divine retirement party in a supernova explosion. Smaller stars, when they die, transform into something known as neutron stars, which are very dense, but not dense enough to trap light. However, if a star is 3 times the mass of our Sun, it collapses under its own gravitational pull, forming a black hole. As these massive stars break down, something peculiar happens near their surfaces. Time itself begins to play tricks. From the perspective of someone far away, time seems to slow down near the event horizon, the final boundary for anything falling into a black hole. It's like the star's clock ticks at a different speed compared to our own. Sometimes, when 2 smaller black holes collide, they merge to form a much larger and more terrifying black hole. If a black hole interacts with a neutron star, they create a titanic nightmare that challenges our understanding. Researchers have been grappling with the size of these vast phenomena for years. Black holes come in 2 sizes, massive and supermassive. There's a vile secret surrounding them that we seemingly can't unravel. Here's the twist: small is relative when it comes to black holes. Stellar mass black holes, remnants of massive stars, can be anywhere from 10 to a few hundred times the size of the Sun. There could be upwards of 10 million to a billion of them in the Milky Way alone. That's a galactic number of black holes that could swallow anything in their way. But wait, there's more. Supermassive black holes are on the opposite end of the spectrum. They are millions, if not billions, of times bigger than the Sun and exist at the centers of giant galaxies, including our very own Milky Way, like a vast, dead emptiness pulling everything towards it. The esteemed physicist Stephen Hawking discussed black holes throughout his life. His lectures were always insightful, but some of his theories couldn't be confirmed due to a lack of essential equipment. However, there's hope on the horizon. A single scientific instrument is changing everything, and we're not prepared for it. It goes by the name of the James Webb Space Telescope, also known as JWST, and it's here to delve into the depths of our universe. Let me tell you, the JWST is no ordinary telescope. It's an engineering marvel, a testament to the power of human ambition. Sure, we've launched other space telescopes before, and they've done their jobs admirably, but this one is on a whole other level. The JWST makes the Hubble, which has faithfully served us for many years, look like a mere toy in the universe. And the price tag for this galactic miracle? An astounding $10 billion. Yes, you heard that right. That's enough zeros to boggle the mind. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency to bring this wonder to life, along with crucial contributions from over 300 universities. Yet we must not forget the risks that accompany such a monumental endeavor. I know this isn't a task for the faint-hearted. The JWST is venturing into uncharted territory, pushing the boundaries of what we know and taking us to places we've only dreamed of. Following a successful launch, NASA recently announced that the telescope has enough fuel to last over twice its minimum mission lifespan. Since its launch, the JWST has made numerous incredible achievements. It traveled over 1 million miles to reach its orbit around the Sun, where it will dwell permanently. During its journey, the telescope successfully unfolded its enormous 5-layer sun shield and giant primary mirror, both of which had to be folded to fit onto the launch vehicle. Now, after NASA has calibrated and adjusted it, the telescope is nearly ready for full operation. Perhaps one of the most thrilling aspects of the James Webb Space Telescope was when NASA announced that it had captured its first images of starlight. The first picture taken by the telescope was of a star called HD 8446, resulting in a cluster of 18 dispersed brights from the star's light captured by the 18 mirror segments on the primary mirror. NASA later released another improved picture of HD 8446, in which 18 unfocused duplicates of the star were combined in a coherent hexagonal arrangement. Once the observatory successfully aligns the individual segments of the primary mirror, it will begin the image stacking process, combining 18 images into one clear view. Thanks to its advanced technology, the JWST will assist researchers in studying the early stages of the universe after the Big Bang. It will focus on what happened after the first stars formed, a period known as the epoch of reionization. This period refers to when neutral hydrogen was reionized or made to have an electric charge again by radiation from these first stars. This involves looking back billions of years, which is only possible with a powerful telescope like the JWST. The telescope will also help researchers discover exoplanets, which are notoriously challenging to identify due to the way they interact with their host stars. Its powerful sensors will be capable of observing these planets in greater detail, including in some cases imaging their atmospheres. Understanding the environments and formation conditions for planets could assist scientists in better predicting whether certain planets are habitable or not. Apart from studying the formation of galaxies, researchers examine galaxies to see how matter is organized on a massive scale. This, in turn, allows us to understand how the universe evolved. The spiral and elliptical galaxies we see today developed from various shapes over billions of years. One of JWST's objectives is to look back at the earliest galaxies to better understand that evolution. Scientists are also trying to figure out how we got the variety of galaxies that are observable today and the current pathways galaxies form and merge. However, most importantly, the James Webb Space Telescope will help us answer the most significant questions of all. Are we alone in the universe? And are we residing inside a black hole? The JWST has already been on the hunt. And guess what it found? Compounds called polycyclic aromatic hydrocarbons, or PAHs, lurking around those massive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures are like the goths of the universe. They're everywhere from distant galaxies to comets in our solar system. Now, they're not just fascinating because they could be the building blocks of life, but also because they help cosmologists track star formation. When ultraviolet radiation hits these PAHs, they become all flashy and emit infrared light, a signal that can be detected by the JWST's mid-infrared instrument, also known as MIRI. And that's usually a sign that there are some hot, young stars nearby. But wait for the surprising development. A bold astrophysicist, Ismael Garcia Bernard from Oxford University, decided to take a look at 3 active galaxies, known as NGC 652 and NGC 731, the creepily-famous Stephan's Quintet, and NGC 749. These galaxies are millions of light-years away in the depths of darkness. Now, what Garcia Bernard discovered will make your hair stand on end. In those central regions where the black holes reign, he found an abundance of PAHs. Sounds great, right? Well, here's where it gets chilling. The radiation near those supermassive black holes warped the PAH's very essence, transforming them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs evaporated into obscurity. Imagine being consumed by the very darkness. But wait, there's a silver lining. The larger PAHs managed to survive because they found refuge inside thin, dense gas-filled clouds. It's like they found their own protective shroud against the horrors of the black hole's fury. Now you might ask why this dark twist matters. Well, you see, it's a crucial puzzle for astronomers trying to understand the conditions necessary for life and star formation in the universe. The presence of PAHs near black holes suggests that even in extreme environments, the building blocks of life can persist. This raises fascinating questions about the origins of life and the potential for habitable conditions in diverse cosmic locales. The discoveries made by the James Webb Space Telescope could illuminate the processes that occur around black holes, potentially offering insights into how galaxies evolve and interact with their environments. Understanding the dynamics of PAHs and their survival in such hostile settings could help astronomers paint a more complete picture of the universe's history. Additionally, the JWST's ability to detect these compounds may lead to more discoveries about other organic molecules in the universe, hinting at the complex chemistry that could underpin life beyond Earth. By studying the environments surrounding black holes and their effects on molecular structures, scientists hope to uncover how different conditions can support or inhibit the formation of life. As the JWST continues its mission, it promises to unveil secrets of the cosmos that have long eluded us. With each new finding, we get closer to answering profound questions about our existence and the nature of the universe. Are we truly alone? Or is life lurking in the shadows of distant galaxies, shaped by the enigmatic forces of black holes? The journey into this cosmic mystery is just beginning, and the JWST is leading the way.